Video, I will show you how to use Excel to do the multiple regression. So this is a sample example for the data set of the housing. You can also download this sample data on Canvas. So in this data set, we have the column. So this column is the value of the house, which we consider as Y. So the house value influenced by many factors. And here we will only consider 3x, the square footage, lot size, and year built. As we learned in chapter 12, for the multiple regression, and we need to consider all the combination, which is y versus x1 and x2, and y versus x1 and x3, y versus x2 and x3, and y versus x1, x2, and x3. So we need to consider the four combinations, and among the four combinations, we need to choose one as the best model. So let's copy paste the data first. So first, y versus x1 and x2. So let's copy paste first. Y, x1, and x2. So Control C, open a new sheet, and Control V. So this is x1 and x2. So we will use the data, click data, and find the data analysis, data and data analysis. So if you don't have the data analysis, you need to add it in again. So how to add in? If you're using Microsoft System, File, and go to Find Options, and on the left side is Add-ins. So if you are using MacBook, the Add-ins is under Tools, Tools. So you will find the Add-ins. Double click this one, and at the bottom go and click Analysis Toolpack. Click here and click OK. So you will have the data analysis here. Okay, and we will open the data analysis. And for the multiple regression, it's very similar as what we did for the simple linear regression. So use the mouse to find out regression here, regression. And the Y input, Y range, use the mouse to select from the first one to the last one. So this is Y. And for the simple linear regression, the x, we only have one, but for multiple regression, we just select all the x. So in here, we have 2x. So use the mouse to choose from the first one to the bottom. And if you have more x, just select all the x. So here, we only have 2x. So use the mouse to select to the bottom. And because I select the title, so I need to click neighbors. If you don't select the title, you do not need to click this. And next one, output range. So click this one, and you can put anywhere empty. So here, and click OK, you will have the result for the multiple regression. And also, as we learned in chapter 12, we need to choose one of the four combinations as the best one. So how to choose them? First, look at the significant f. If it's smaller than 0.05, and here is e negative 16, very small. E negative 16 is 10th negative 16 power, so it's smaller than 0.05. So the model is significant. And second, we need to look at all the p-values. However, here the p-value for intercept, so it's 0.19708, is bigger than 0.05. So this model is not the best model option because p-value is bigger than 0.05. So we will not consider this one as the best one. Now let's consider x1 and x3. So let's copy paste the data to a new sheet, x1, x3. Control C and open a new sheet, Control V. So we will do the same thing again, data and data analysis and regression, and click OK. So Y is the Y range. You just select the Y range from the first one to the last one. And X here, the X range here is from the first one to the last one. And because we have the title, so click the neighbors here, and also the output range, you can put anywhere empty, maybe here, and click OK. Now, let's see the model is significant or not first. Significant F here. E negative 17, very small, so the model is significant. And look at all the p-values. So here, all the three numbers are smaller than 0.05. So this is one of the candidate. So one of the options. Okay, now let's look at the adjusted R-square. So adjusted R-square is here. Let's highlight it first. So this is one of the candidate. Okay, let's see one more. So go to the original data, Y, and copy paste the X2 and X3. So Control C to open to a new sheet. Again, do the data and click data analysis and find a regression. Okay, and the same. Y, use the mouse to select the first one to the last one. And here, X, we have X2 and X3. Select all of them from the first one to the last one. And also click the neighbors and output range, put anywhere empty here and click OK. Now let's see again. The model is significant or not. So we look at the significant F here. And it is E negative 10. Very small, so the model is significant. And next, look at the p-value. So all the p-value are very small, smaller than 0.05. So this is also one of the options, one of the candidate. So we need to look at the adjusted R-square. So let me highlight first. So the adjusted R-square is 6947, and compared to the last one, 0.8568. So far, this model is better than this model because the adjusted R-square is higher. So right now, so far, this one is the best model. The Y versus square footage and year built, X1 and X3. So we need also to consider the combination of the X1, X2, and X3. So we will do the data and data analysis again. Regression. And Y is the price, so select from the first one to the last one. And input range. So right now we have 3x. So from the first one to the last one. And click neighbors because we have the title and also the input range. Put anywhere empty, maybe here, and click OK. So let's see whether this is one of the best candidate. So model first, significant F. And here is E negative 16, very small. So the model is significant. and look at all the p-value. So p-value here, it looks like all the p-value are very small, smaller than 0.05. So this is another one of the options, one of the candidate. And we look at adjusted R-square. So adjusted R-square, 0.871169. Compared to the last one, 0.69 is better. And compare the last one, 0.856. So far, this one is the best one because the adjusted R-square is the highest compared to the model of the square footage versus the year built. So this is the best model. So we will use this one to predict in the future. So this is the best model. And here under the coefficient, this is the equation for this model, which is y will equals to the intercept. So it equals to the intercept negative 4, 8, 9, 1, 2, 7, 4. So plus the slope. So this is the slope for square footage. So 138 and times x1. x1 is the square footage plus this number. So this number is the slope for lot size. So plus 27 and times x2. And plus the year built slope is 2,588. Let's just keep the integers times x3. So that you can use this equation to predict the y value if you know any number of the square footage of the house, lot size of the house, and year built of the house, so you can predict the y value of the house, the value of the house. And after we find out the best model, so usually we will find out all the outliers. And for the outliers, you already find it in your individual part. So delete all the outliers and redo the best model. So for example, this model, the best one is 1, x1, x2, and x3. So you redo the best model and figure out whether there are any changes. So usually after deleting the outliers, the adjusted R-square will increase. And lastly, and you need to check the assumptions. So this is the best model, and for the best model, you need to click the residue plot, the line fit plot, and normal probability plot to check the full assumptions. And for the assumption check, please watch the other videos for the assumption check. So click OK, and you will have all the graphs and check one by one for the full assumptions. So that's all for this video.